Hello everyone! This company built the very first ever portable UAV designed for indoor use and GPS-denied environments, flying comfortably near people and efficiently capturing data. All that in what I love this, in a Dronut-shaped drone. Let me introduce Cleo Robotics. Hello everyone, welcome to another episode of Builder Nation. I'm your host Sam, and today we are joined by Simon Czarnota, CEO and founder at Cleo Robotics. Welcome, Simon. Thank you very much for joining us today. Could you please introduce yourself a little bit?
Sure thing. Hey, Sam, it's great to be here. So like you mentioned, my name is Simon Czarnota. I'm the co-founder and chief technology officer at Cleo Robotics. I've been with the company since its inception. It's been around 6 or 7 years now since we started. My background is mainly software engineering. However, I have done some personal projects in electronics, and I would say that both, software and electronics are very big, have always been very big passions of mine. Ever since a young age, I've loved to program. I loved the idea of being able to make a computer think and do something that I wanted it to do. And then, I very quickly kind of extrapolated that idea to robotics as well. And that opened up a whole new, you know, like slew of ideas of I could make robot or computers, think whatever I wanted them to think, but now I could make them do whatever I wanted to do. So that was, kind of a very natural transition for me, from my interests to Cleo Robotics, which, like you said, we build, this very cool and unique aerial vehicle that we like to call the Dronut because it looks like a donut. So it's a play on words. It's very cool.
I agree, it's very cool. The tech is very cool, and we're definitely going to be touching that a lot throughout this interview. But actually, I wanted to circle back just before this to what you mentioned about yourself, right? Which is that you've always liked making, computers think. You actually began studying programming, right? Software engineering. You've been coding for quite a while now. You actually spent around a year working at Cisco. So I have to ask you. I mean, this experience at Cisco as a software engineer, how did it translate into you actually building your own hardware-oriented tech in this case, right? How did you go from Cisco software engineering to this whole drone industry?
Sure. So that's a really good question. So Cisco was an internship that I did during my university studies. It was a one-year internship, and the role that I had there was in their cybersecurity team. So I helped build cybersecurity software, test it for commercial and military use. They had customers kind of all over the place. The reason why I chose Cisco for my internship as opposed to like a more hardware oriented company. Again, most of my experience, professional experience, and my field of study, which was software engineering, was very software focused, right? This electronics and hardware interest, it was a personal interest that for many reasons I decided not to pursue in university academically, but it was a very heavy kind of personal interest that I've had, taking things apart. I've done that for as long as I can remember, opening up old, destroyed, toasters and whatnot and try to see what's inside and how they worked. It always fascinated me, right? So I always kind of wanted to learn how they worked and how I could build them. So my first professional experience in university was Cisco Systems, where I worked as a software engineer. It's actually a funny story because that experience, so I like to think of myself as like a lifelong learner, a lifelong entrepreneur, right? Like I've had this inkling to start something, to do something on my own for a very long time. But I've always thought of it as kind of like a side thing, right? It's like I'll have a job, I'll make money, and then I'll pursue my interest, and maybe something will come of it on the
Right.
side. But with this experience, in university, with the first kind of like real idea of what being a software engineer in the real world would look like, I was honestly a little demotivated by the lack of impact that I was
Hmm.
making in the company. I mean, now the way that I like to sell Cleo to potential interns or potential employees, we're a startup, we're a small company, so your impact is really big, right? Whereas if you work for a big company, your impact is not to be understated, but at the end of the day, it's pretty small, right? You work on a
Right.
small piece of a product or a software, and that's exactly what I was doing, you know. And then I thought, you know, it's nice, it's a stable job. I make money, you know, it's I get to use my skills, is great. But you know, I thought in that moment, is this really what I wanted to do for the rest of my life, right? And very quickly, I realized the answer was no. The answer was no. So that was the kind of the turning point in my life where I really seriously considered, you know, starting a startup and doing something like this full time professionally, you know, for the rest of my life. You know, I love what I do. I love this path and being able to forge my own path. Um, so I'm really glad that I made that decision, but that was kind of the turning point, right? And then as far as why Cleo Robotics and why a Dronut, why a drone, that's kind of a separate topic, kind of unrelated to my previous experience. But so I'm from Calgary. So I was born and raised in Poland. I came to Canada when I was 10 years old.
Mhm.
So I did my university studies in Canada as well. I was from a town called Calgary. Um, Calgary is very oil and gas focused.
Right.
There's a lot of oil exports from Alberta. That's very well known. So that industry was the predominant industry in my city, right?
Right.
Uh, so when thinking about startup ideas, you know, when I was brainstorming things with my business partner, uh, you know, naturally our kind of thought processes went in that direction of, you know, what could we do where we're at, basically. That made sense, right? So during one of my previous internships, a little shorter than Cisco, I did work for an oil and gas company, so I kind of had an idea of the things involved uh, in the process of extracting that oil.
Right.
But my co-founder had firsthand experience with that, right? So he was the one who actually went out into the field, amongst other things. He did inspections of the pipelines and of all the equipment involved in the process of extracting that oil, right? Um, and so, you know, we were basically brainstorming, and you know, we thought this dangerous job that he has to do and that other many people around the world have
Hmm.
to do, right? Of entering these confined spaces to do what, right? All they did was just look around, take notes, take some pictures. It's all just visual inspections, right? But
Okay.
they're very dangerous, they're very costly, they're very inefficient, takes a lot of time to do it. The inspectors usually have to put on, you know, protective clothing, depending
Right.
on
It's
what they're
risky.
inspecting exactly. It's very risky. It's very risky. There's fumes, chemicals inside. You don't know what you're going to find, right? So we thought, you know, that was kind of the you know the time when drones were becoming very popular. Um, you know, more and more people were playing with FPV drones. They didn't really have any of this autonomy that drones have now. They didn't have,
Hmm.
you know, position hold, LiDAR, 3D scanning. It was
Right.
all very brand new. So with this new robotics, you know, kind of system, these toys that were coming out, we thought, well, why don't we just use a robot to do that same job instead, right? And kind of save that person the need from entering those environments and putting themselves at risk. Um, so that, you know, got us down the, you know, kind of down the rabbit hole of, okay, fine. So let's say we wanted to build a robot to do these jobs. Like, what would that robot look like? What would it have to do? How would it work?
Hmm.
Um, and very quickly, you know, we thought about ground robots. Okay, well, those obviously don't work because you can't go up and down,
Right.
vertical scaffolding, vertical, basically entryways and whatnot. Drones obviously don't have that problem, but the existing drones, and even now to this day, you know, most of them have exposed propellers, which makes
Hmm.
them very dangerous to themselves, makes it very dangerous to the environment, and it makes it very dangerous to any people that might be around the drone.
Right.
So those existing drones also went out the window as far as the solutions for this problem. But we took a pause and we're like, okay, well, the existing drones don't fit. But what if we could solve the problems that the drones have? What if we could enclose the propeller somehow? Um, what if we could build essentially, you know, I have this very vivid memory of the conversation that we had in which we we said, why don't we just build the best drone possible? Just forget everything we know about drones,
Mm-hmm.
forget everything we've learned up to this point. What would the perfect drone look like, period? Right? It would obviously be safe, because why do you want a dangerous drone? It would obviously be small, it would be efficient, it would be very capable. So armed with this idea, we kind of went to the drawing board and we just
Mm-hmm.
thought, let's just come up with something that, whether it's feasible or not, let's just think outside the box and really explore this idea.
Right.
And long story short, we ended up with basically the first iteration of the Dronut, which was actually a lot smaller than what you would see in any of our videos now. Like our initial prototypes were literally puck sized. They were like
Okay.
hockey pucks. They were very, very
Yeah.
tiny. Um, and all they did was fly and stream video. They also didn't have any of the fancy autonomy, but they solved all the problems that we identified. They were very small, they were very compact, um, they were very performant in the sense that why are quadcopters like why are all quadcopters so big, right? Like if you look at our drone at even in its current state, which is significantly larger than where we started off from, why are they all so much bigger than that? Why can't they be this small, right? And the
Okay.
reason why is because the smaller the propellers get, the less efficient they become. And a
Right.
quadcopter has multiple of them. So you have multiple tiny propellers, all of which are inefficient. So a small quadcopter basically can't fly as long, it can't carry a significant payload. That's why they're all larger, especially if you want a amazing camera or a 3D sensor, 3D
Mm-hmm.
LiDAR sensor or something, right? Um, and that's one of the advantages of the Dronut. So for those who haven't seen it, who might be watching this, the way that the Dronut looks like is it's a ducted fan. It's a coaxial ducted fan. What that means is there are two propellers, one on top of the other, and then the whole thing is enclosed in what we call the shell of the Dronut. So the
Okay.
shell of the Dronut looks like a donut. It encloses the two propellers that are in the middle, and then all of the electronics, all of the brains, all of the power systems, everything sits inside of the shell. So if you think of a quadcopter, which has the body in the middle and the propellers on the outside, we kind of took that idea and we inverted it. So we put the propellers in the middle and everything
Mm-hmm.
else on the outside. So that solved, again, all the challenges that we faced, which was safety. The propellers being larger were more efficient, so we were able to fly for longer than a quadcopter, a typical drone that's the same diameter. We can
Mm-hmm.
fly for twice as long, if not even more. We can carry significantly higher payloads than other drones of the same size. So, you shrink the drone, but you don't lose any capability. You
Right.
actually gain capability. So, you take a drone this big, which is a quadcopter, you take a Dronut, which is, we have pictures of the Dronut on top of other drones, and it's like a quarter of the size, and it does the exact same thing. Flies for the exact same amount of time, but it's a quarter of the size. It's tiny,
Right.
right? So who wouldn't want that? It's perfect, right?
Right,
Um,
I agree. It is perfect. This actually raises a few questions. I mean, the whole insight that you've given us raised a few questions for me. First of all, I want to touch the part of the industry that you mentioned, that sort of this concept came from, right? Which is this oil sort of environments that has fumes that are dangerous. Um, the drone itself is oriented for indoor usage. That doesn't necessarily mean for indoors in your house, right? But also in these confined spaces. Are there any sort of adjustments, necessary adjustments you have to make to the drone to make sure it withstands the specific maybe hazards around the environment is going to be used on? For example, in this case, this oil thing, or is it sort of like one size fit all?
yeah, that's a great question. The short answer is no. So in its current configuration with the current use cases that our customers are using the Dronut for, it does not need any special protections. So the fumes and chemicals that I mentioned, I mean, not all environments that need to be inspected have those,
Right.
but they're mostly hazardous to humans if inhaled in large quantities. Um, Obviously we don't, the Dronut, like any other device, should never be used in an environment that has fumes that could catch fire or something like that.
Right.
But that goes the same for anything else that you would put in that environment, right? It's not exclusive to the Dronut. But I would say, 90% of the spaces that the Dronut is used in, or that the Dronut is intended to be used in, there's no special considerations that need to be taken. And you said that correctly, that the Dronut started off and still is primarily used indoors and in confined spaces to basically fill the gap of, there's nothing else in the market that can do that job.
Right.
But at the same time, it is just as capable flying outdoors actually as other drones. So even though it bridges this kind of capability gap, you don't lose any performance in a typical environment that drones operate in. I mean, I obviously wouldn't compare it to a drone that's 3 feet in diameter that can fly in huge wind gusts. But if you take a drone outside, it'll perform the same. So it can fly just as well outside as well as indoors.
All right. Thank you very much for that. I was very curious about that because of these sort of extreme case scenarios you mentioned. So thank you very much for that. The second question that I had regarding your prior answer is you mentioned that you sat down and you said, okay, let's forget everything we know about drones. Let's come up with something new and something fresh. How long was the R&D phase of, between actually, just getting this idea, drawing up things until actually having the first prototype of this drone that has the propellers in the middle and the brain sort of surrounding those? How long was the R&D phase?
So, like I mentioned, my background is mainly software and electrical, right?
Right.
My co-founder's background is mostly mechanical engineering. So none of us, or neither one of us, had significant aerodynamics background or knowledge, right? So I just want to preface what I'm going to say with that, right?
There was a lot of learnings.
So
I can see it coming.
there was a lot of learning, and I mean, I didn't mind. I love learning, right? I mean, everything I learned, I pretty much self-learned anyway, so this was nothing new to me. But the idea for the Dronut, its shape and its control mechanism, which is actually our patented thrust vectoring mechanism, which is kind of our secret sauce of how the drone flies and is able to stabilize itself and move around. So the idea for that whole mechanism, we had that from the get-go. Like we came up with that relatively early. The process of actually getting something in the air, flying, I would say it took about a year and a half for the first prototype.
All right.
So that was, going through. I mean, we were blessed in more ways than one, in that, for example, 3D printing technology also was coming out around that time. So it made, this rapid development very feasible for us. We could try out new ideas relatively quickly, right? But we learned one thing at a time. We learned a little bit about control systems. We learned about aerodynamics. We learned about actuators. All these different things that were involved in it. So it took a little bit of time, but again, I don't pretend to know everything. I don't think anyone does, and part of this journey is learning about things that you don't know about, and I am an engineer at heart, and I love learning anything engineering related. So it's it was a great journey, and I don't regret anything.
I think we're very alike in that way. It's amazing, and honestly, whenever you embark yourself in such a challenge like this one, you learn a lot of stuff that you didn't even know you had to learn. Right? It's amazing.
Yeah.
But now I do have a question that is engineering wise, a lot more related to this. Now you already mentioned that it took some time for you to develop the way for you to not just fly the drone but also steer it, basically, right? Like the way a normal drone works is sort of a helicopter. Like the helix, they have to sort of incline so that the air pressure goes a different way, and the same goes for regular quad drones, for example. How did you address this, having like just one one drone, right? Like with the you mentioned that the propellers are one on top of the other. So how did you address this for steering and for this versatility? You already mentioned it is your patented technology, but how does it work?
Sure. Yeah. So ducted fans as a technology are not new, right? The idea for enclosing a propeller in the duct is not new.
Right.
We would never take credit for coming up with this idea, right?
Right.
Trying to make vehicles that utilize this idea dates all the way back to the 1950s. So ever since then, there have been numerous government agencies, private companies that have been trying to build a ducted fan aerial vehicle of any scale. I mean, the
Right.
first prototype that we were able to find, it's a manned system. Somebody's standing on top of it. So everything from that size all the way down to the Honeywell T-Hawk, if you're familiar with that. It's basically like a bucket-sized ducted fan that's gas-powered. So it's
Okay.
similar in that, but it's also very 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 different from what we've done, right?
Right.
So the idea of these ducted fans is not new. The reason why we haven't really seen anything commercialized until the Dronut is because ducted fans are notoriously difficult to control. And what I mean by that is they're notoriously difficult to come up with a system that will allow them to tilt
Hmm.
and then to maintain that tilt while they travel.
Right.
That's been a very, very difficult challenge to solve. So our patented thrust vectoring technology basically overcame that problem in a way that we were able to generate orders of magnitude more control than other attempts at getting ducted fans to work. So traditional ducted fans, you have the duct, you have the air flowing through it. The most run-of-the-mill way to try to get them to try to get it to fly around is to have these vanes or basically flaps at the bottom that sit in the airflow,
Right.
and then they rotate to redirect the airflow, right? So they're always there, and they rotate. Um, so that obviously makes the drone taller because you
Hmm.
have to have those vanes in there. And again, they don't generate a significant amount of control. So what we've done, kind of our light bulb moment,
Hmm.
came in the way of we looked at rockets, we looked at jets, we looked at aircraft, and we thought, okay, well, this already kind of exists. It exists in not in a typical way that we're trying to get it to work, which is the duct on its own
Right.
without anything attached to it, but there are technologies that already utilize this idea kind of, right? And how do they do it? And what we notice is that their flaps or their control surfaces don't sit in the exhaust, they sit around the exhaust. So they sit on the periphery, right? They're also always there, but they move and they rotate and they redirect the airflow this way. And we
Okay.
realized that it was the length of those surfaces that allowed higher airflow redirection, right? But we didn't want to
Mm.
add those to the Dronut, making it double the size, right?
Right.
Making it
Right.
double the
Right.
height. So what we came up with was this system to retract the flaps into the shell, into the body of the Dronut. So if you don't need any control, then they're not there. But if you do need
Mm.
control, then we can insert them and then redirect airflow and create control. So the flaps can be a lot longer than typical control attempts for ducted fans without
Hmm.
actually increasing the size of the vehicle whatsoever. So if you look at the drone, and if you don't know how it's controlled, it just sits there with the flaps retracted, and you look at it and you're like, well, how does this thing fly, right?
Right.
Because the flaps are hidden, which is the whole point. But then if you see it in flight, you can see, and you can see this on our website, for example, a little GIF of how it works. You can see the flaps basically go in and out constantly to adjust for
Okay.
what the drone is experiencing, right? So if you want to travel forward, you insert the rear two flaps, it redirects, vectors the thrust, the whole vehicle rotates and it travels forward. So that was our light bulb moment. That was what allowed us to accomplish something that no one has been able to accomplish for decades, right? Again, all of the advantages that I've mentioned, people knew about those, right?
Right.
Ducted fans have advantages over typical propellers over other drones. But it was this inability to control them that has prevented people from commercializing this technology. So we are the first company that has successfully commercialized ducted fans.
And that's actually a very impressive feat. But I do have a question with this. So you already mentioned that the main complication about this is this control, right? Now, you being the software side of the entire Dronut, how complicated was it actually to transform this into an autonomous drone that it works with lidar, that works with with the streaming, and that can sort of, well, reach real autonomy. Sorry. How did you do it? How hard was it?
Sure. Yeah, that's a great question. So, in it, what we want, we didn't want to overcomplicate anything, obviously,
Right.
right? The more you overcomplicate something, the more time, effort it's going to take to develop it, the more into the unknown you kind of venture, and then the longer the entire process takes. So, our first, maybe not the first, but the approach to the controls that ended up working was, we thought, okay, drones exist, drones have control systems, drones fly.
Hmm.
Great. How can we, again, on the software, on the control systems, on that level, how can we make this drone as similar to a quadcopter as possible? So basically, how can we how can we come up with this almost like this translation of all the things that are unique about the Dronut and
Hmm.
translate them into the space of existing drones so that we could use as much existing solutions as possible, right? So once we stumbled upon that idea of trying to, I'll call it this translator between, we use flaps instead of motors for our control
Uh-huh.
and for our rotation, right? We use motors which are separate from flaps for thrust and yaw. So
Right.
how can we combine those and basically translate their reaction to be similar to what the quadcopter would experience, right? And once we had that translation, a lot of the off the shelf stuff worked, right? Like, right now we do have a lot of custom software, but a lot of the control system is off the shelf. Again, once that low level translator is there,
Right.
then it acts like a system that all these things are already built.
Drone that you built, right, which you mentioned was just a pocket-sized one that didn't really have a lot of
Mhm.
tech inside it until right now the X1 Pro, I believe it's called, that
Yes.
has an AI engine, it has a lidar, it has like all of this tech that of course means hardware. How many iterations did you have to go through all these paths?
Sure. I would say it's been around 4 different generations
Okay.
of the vehicle. And in each generation, what drove that development was, increase in capability, right? So initially we had, a small puck that flew, but it didn't fly very well. You couldn't fly very fast, right? So we made that a little bit bigger. That allowed us to fly faster, but it was still physically just too small to fit any kind of, like you said, AI engine, any kind of advanced compute, any kind of advanced sensors into it, right? It was just the sensors were too big. It's not
Right.
that the vehicle couldn't do it, just too big, right?
Yeah.
So then we increased the size a little bit more to fit those in there. And then from there, it was optimization, right? So we realized, if we increase the diameter by 5%, maybe we'll get 15% more efficiency or 15% more control, right?
Mhm.
So we tried to find this sweet spot of, big or bigger and very performant, efficient, all the things that I've mentioned, but not too big so that it could still enter all these environments, all of these spaces that our customers need to enter, right? So we started with the smallest thing to prove the technology worked, and then we grew it as the needs grew as well to
Right.
provide our customers with something that was actually usable. And again, I mean, at the end of the day, what we want is to provide our customers with the best product for them possible, right? And again, if you have to increase the size a little bit but get a lot of gain from it, then within reason, we'll do it.
Right, and that's actually pretty. I believe it is the perfect way to sort of find different go-to-market strategies for your drone. So thank you for sharing that. But now that also triggers another question for me. So you already mentioned in throughout the conversation that uh, around 90% of the use cases for your drones don't require anything different. They might be used for just regular inspection, maybe in manufacturing plants and whatnot. Are there any plans to sort of shift the vision of the Dronut for maybe indoor recording, but like for a more professional recording type of thing? In this case, I assume that the streaming part that you have is maybe not oriented for for high end productions, maybe. But given that this is very well built for indoor use because it's so safe, are there any plans to address that industry?
Sure. So I would expand on that a little bit, and I'm going to answer that question in terms of the consumer market in general. So not
Right.
just videography, but for consumers, right?
Right.
Um, so, you know, to be frank, at the moment, we don't have any plans to go into the consumer market. I mean, the price point of the Dronut, um, re reflects the capabilities.
Right.
It reflects the sensors, the compute, all of the different components that go into it for it to be able to do the things that it does, right? So
Right.
that price point, today is not really feasible for the consumer market.
Okay.
Um, However, the platform itself, the great thing about starting small with a small drone and growing it showed us that this thing is very scalable.
Yes.
Not that we have any plans for this, but there's no reason why you can't scale this to be like a personal transportation vehicle, even, right? Like anything. The larger it gets, again, the larger the propellers, it kind of still follows the same logic.
Right.
More efficient, even more performant. You make it double the size, and you can double the flight time, triple the flight time. You can add crazy cameras. You can really do amazing things with it. So the scale is there. Technically it's very possible. But again, due to those restrictions, we don't think it's the best use of our resources, and it's the best market for us to enter at this time.
All right. Totally understand that part. I mean, it's very cool, and I believe it's very wise to just stay in one path. But it's also very cool to know that you already have sort of that knowledge, right? In case you wanted to address it.
Right.
I mean, it was a cool question that I wanted to ask because I at some point I saw a video of somebody like doing this super cool inside sort of
Mhm.
recordings, and it was kind of like a track, right? But anyways, thank you very much for sharing all of that, all of that with me. Now, I want to jump a little more into the current use cases that the Dronut has right now, right? You already mentioned that um, it is used for inspection, for just visual inspection of places. We know in your website you mentioned that a lot of it is, for example, for manufacturing lines, sort of keeping it. What are the most common use cases for the Dronut right now, and what do you believe is the ultimate use case for it?
That's a very interesting question. So I'll start with the first half. Um, so currently there are two use cases that are the most popular. So the first one, as we've heard many times, is indoor inspection, right?
Right.
Confined space, what we like to say confined space inspection. So in commercial settings, this can be anything from power plants, nuclear power plants, manufacturing facilities, warehouses. It's either flying around a space where you can't really afford to have an open prop vehicle that could hit something and break a $2 million piece of equipment, right? So to fly around and inspect the plant itself, or to fly inside of a piece of equipment and perform that inspection, um, basically instead of a human, right? So those are the two biggest, or those are the two
Right.
use cases for the commercial market. Now we have a lot of interest from law enforcement as well as the government side for
Mm,
basically ISR applications. What ISR stands for is intelligence, surveillance, and reconnaissance.
right.
So in the same spirit of removing that need from a human having to enter a dangerous situation, that can be expanded to, again, law enforcement officers, for example, right? When they respond to a call and they don't know what situation they're going to be presented with,
Right.
instead of putting themselves at risk, which slows them down. Understandably, I wouldn't want to just rush into an unknown situation either,
Of
right?
course.
What they can do instead is deploy something like the Dronut very rapidly. Uh, Again, one of the best things about the Dronut as well is it's extremely easy to fly, so almost anyone can fly it with very little prior experience and basically enter that situation, right? And get eyes on the inside, stream video, and see what they're being presented with before they ever enter that situation
Right.
themselves, right? So, so those are, the industrial inspections as well as this reconnaissance and surveillance side. Those are the two biggest use cases that, we get a ton of interest from. I mean, every week we get dozens and dozens of requests, for information about how this can be used to inspect this or this, right, from companies. I mean, it's really incredible to see like
Right. We're back. We're back over here. Apologies for that. Internet went down just for a minute over here. Let's circle back to where we were standing, right? Simon, you were mentioning that the two most common use cases at the moment for the Dronut were on the one side for inspection and on the other side for law enforcement for this ISR. So, so that is
Recording
those were
in progress.
the two use cases, right? The second part of the question that I asked you back in the moment was, what do you consider is the ultimate use case for the Dronut? That what you would consider the perfect scenario for it?
sure. So the way that we like to think about the Dronut is not in terms of any single use case, right? Like we're not trying to build the best inspections drone. We're not trying to build the best whatever drone. Um, you know, what we, the way that we think about the Dronut is it's a data collection platform at the end of the day, right? Like its advantage and its strength is in access, in providing access to these environments where nothing else was able to provide that access prior to the Dronut, right? So the Dronut is able to go into environments where no one else can go, where no other robot can go, where no other drone can go. And what does it do when it's there? It can collect data. Um, so the Dronut has a lot of really cool and interesting sensors on board, right? It has 3 cameras. It has a 3D LiDAR. Let's do it.
All right, so we're back once again. Again, massive apologies for these inconveniences with the connectivity. Apparently, there are some issues going on right now. Guess it's part of having, being during rainings, pretty much. But anyway, so Simon, apologies for all of this delay and for these slight, disconnections. Good to be back. Good to that we can pretty much wrap this interview up. Massive apologies for that last answer we didn't get to hear regarding these use cases. If you wanna just pretty much wrap that one up before we continue here, that would be great. For
Sure thing.
for these uses.
Sure thing. Yeah, no worries, Sam. Yeah, basically, what my point was, we're not building a single drone that's, the best drone for any specific use case. We see the Dronut as a data collection platform that can really provide data and insight that was previously unobtainable in these environments, right? So the ultimate use case, I would say that we're building, the ultimate data collection platform. Um, Again, we have, a number of cameras, 3D LiDAR on board, so we can do a lot of really, really cool and interesting things. So, that is our goal. That is our goal, to build the best data collection platform that is, very easy to use, that is extremely intelligent, that can make decisions, that can fly autonomously. That is the dream.
Right, and that's actually pretty cool. Especially, I understand that this data connectivity is for, well, in the end, it requires this mobility, right? Just a few weeks ago, we had an interview with Guillem de Marliave, who who was the head of this company that builds tethered drones. So basically, it's sort of like, tower stations that would
Hmm.
that tether would feed them with power, and then the data transfer. So it would allow them to fly a lot longer. In this case, it's the same use, but it's different, right? With this mobility that is required. So it's pretty cool to know that that is how it works. Thank you very much, Simon. But now I believe that we are definitely entering the end of this interview. We had a over 45 now, almost 50 minutes of really cool conversation. I have a question for you that is a little less oriented in the technology and in the hardware aspects of all this, and more in your journey as a founder, as an entrepreneur. In the end, that's what you are, and also a self-learner, which I believe is key to
Hmm.
this question. What is that one advice that you would give any young entrepreneurs out there who want to start their own path, especially like in your case, coming right fresh out of college? Like you came out of college in 2016, I believe, and in 2017 you were already killing it with the Dronut. So what is that advice you would give this young person?
Sure. Thinking about the advice that I would maybe give myself at that age, right?
That's a nice
Um,
way to see
you
it.
know, I yes, I mean, I know that a lot of startup founders are engineers, right? A lot of them have that technical expertise, have that technical inkling to build something cool. And I would like them to realize that, building something is extremely rewarding, but that is a small part of building a successful business, right? So building a successful business, having a startup is a great goal. It's a great journey that someone can undertake. But realizing everything else that's going to be involved, you're going to have to talk to investors. You're going to have to sell your drone. You're going to have to, or not drone, but whatever the person decides to work on, right? You're going to have to market it. You're going to have to spend a lot of time doing the things that you might not have thought that you're going to have to do, right?
Right.
You're going to have to spend a lot of time not building and not engineering, uh, and basically, doing all the things you need to do to build a successful startup, a successful company, right? So if the advice that I would give is if that's something that's interesting to you, you should definitely pursue it, but don't go into it blindly, right? Have that foresight of everything that's going to be involved in the journey, and that's going to have a number of advantages down the road. You're going to be way more likely to stick with it once you actually have to do those things in order to
Right.
succeed, once you actually have to raise money, once you actually have to hire people, right? If you consciously realize you're going to have to do that and not just build cool, amazing things, then, I think that's the best thing you can do to be successful.
And I believe that is it's sort of the perfect way to make somebody understand that this journey of founding a company, of running a company, of being your own boss, as some people call it,
Hmm.
is not as easy as it looks. I mean, it's definitely a lot more time taking than what people realize. There is this one quote from Alexandra Saturain, I believe. She's the founder of Eight Sleep, and she gave a really cool quote saying that people don't understand that you spend the first 10 years of your company just building it without it actually being
Hmm.
something more, which I believe is the perfect way for people to understand that yes, indeed, building a company takes time. So Simon, thank you very much for giving us all that insight. It's actually pretty cool. I mean, you're also really really young and you already came so far. So I personally expect to see great things from you. I personally expect to see. I want to just follow your journey. It's amazing. So thank you very much for that. And finally, where can we find you? Where can we find the Cleo Robotics and the Dronut? Do you have any social media handles? Your website?
Yeah, yeah, we definitely do. So, I mean, we have our website, which is cleorobotics.com, and Cleo is spelled Cleo, robotics.com. And you can find us on all the, social media you'd expect. We're on Twitter or X, whatever you want to call it. We're definitely on LinkedIn. That's where we post a lot of our videos and a lot of our journey. We have a YouTube
Very
channel
cool.
where you can see some of our thank you, where you can see some of our drones flying around and the different environments where it operates in. So definitely check out the YouTube channel and yeah, if you want to follow us closely, then LinkedIn would be a great place to follow us.
I do recommend the YouTube channel and LinkedIn. The videos you have of the drone is actually pretty cool. And also in your website, I really like this demo of the drone flying around somebody. I don't believe that's you,
That's me.
right? Oh, that's you?
That is me.
Oh, it's really cool. It's really cool. I really
Thank
like
you.
that
Thank
video and how you hold it. Anyway,
Yes.
guys, thank you very much for being here. Remember, you can find more information, interesting articles, and interviews directly on our website, buildernation.io. We're going to love to hear from you. Thank you very much for being part of this community, and we're going to see you the next episode. And Simon, thank you very much again for this. Apologies for those slight hiccups in the streaming. We were so lucky to
No
have you.
worries.
Thank you.
Thanks, Sam. It's a pleasure. Take care.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic 3-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.